All right, our lesson today is going to have a lot of vocabulary, but the concepts themselves are pretty simple and not too hard to keep straight. So this first slide, we're just talking about some vocab that we've already talked about before. Vertical angles, you all know, are angles that are formed by two intersecting lines, and they share a common vertex. So I'm just going to draw a little example. You can look up a definition if you want to, but vertical angles, remember, are these that are kind of across from each other, and they are congruent. So we need to remember that about vertical angles. Linear pair are two angles formed by lines including opposite rays, and they share a side. That's our official definition. Honestly, we're just looking for two angles that are right beside each other that form a line, and we know that those are going to be supplementary. They're going to add to equal 180. Complementary are two angles that add to equal 90 degrees. So they could be adjacent or they don't have to be. So for example, this angle 40 degrees and 50 degrees, those are complementary angles, even though they're not touching. And then the same for supplementary, we can draw that different from linear pair. Remember, supplementary just means they add to equal 180. So I've got a 100-degree angle and an 80-degree angle. So if we look at some examples, I've intentionally given us examples that have all of the same numbers so that we can see kind of how they're different to solve. So this first example is an example of things that are vertical angles, which means the angles across from one another are congruent. And because they're congruent, I can set them equal. So this I would set up as 3x equals 5x minus 10. And then if I was to solve that out, I could get negative 2x equals negative 10, so x equals 5. And if we wanted to know the angles themselves, we could take this value and plug it back in. So that would give me an angle of 15 degrees here, and when we plug it in, 25 minus 10 is also 15 degrees. That's what we want. Now, we could, using what we know about linear pairs, notice there are two linear pairs here, so we could actually find this other pair of missing angles by subtracting from 180, which means this other angle here is going to be 165 degrees, and then the same for its vertical pair on the top is 165. All right, question 2 is a little bit different. So question 2 is not vertical angles, which we probably should have labeled on the first one. All right, question 2, they say that these two angles equal 90 degrees. So this is an example of complementary angles. And I'm just kind of giving some shorthand here. Complementary angles, we know those are going to add to equal 90 degrees. So that means I've got 3x plus 5x minus 10 equals 90 degrees. And if I solve that out, let's see, 8x minus 10 equals 90. So 8x is going to equal 100, and that's not going to work out very well for us. We're going to get a decimal. All right, but that's okay. That's going to give us x equals 12.5. And so when I plug those back in, I'm going to get 37.5 for the first angle and 52.5 for the second angle. And again, that kind of checks itself because these two numbers do in fact add to give me 90 degrees. And remember, this one I did know was 90 because they specifically gave me the box there. If they hadn't, I wouldn't have been able to set up that problem without more information. All right, then my last example here gives us something that is a linear pair, and so we could actually name that as a linear pair or as supplementary. And either way, those angles are going to actually add to equal 180 degrees this time. So if I set this one up, this is going to be 3x plus 5x minus 10 equals not 90 anymore, but 180 degrees. So I'm going to get to the same point. My math is going to say 8x is going to equal, 190, which will give me that x equals 23.75. And then I'm going to plug those back in for us real quick. All right, and I'm going to get 71.25 for the angle with 3x and 108.75 for this other angle, which again does check because if I add those measures back together, I'm going to get 180 degrees. All right, so this is a quick example of how all three of those are different. Let's look at a little bit more challenging problem. Okay, so here's a word problem. It's going to get a little bit tricky, so let's just kind of read through the problem and then get some keywords going on. So we've got the measure of an angle that I don't know, and then is twice, we know that means it's going to be double, the measure of its supplement. So let's kind of take those pieces and set up an equation for ourselves. So the measure of an angle, we don't know it, so that's something we could call x, Is, that's a keyword for equals. And then twice the measure of its supplement. That's going to be 2 times something. So and if I write an equation here, I'm going to have x equals 2 times the measure of the supplement, right? I've got an angle that I don't know and 2 times the measure of the supplement. Now, let's think about how you could find the supplement. If I told you, so supplement means 2 angles add to equal 180. If I told you one of the angles was 30 degrees, my guess is you could come up with the other angle is 150. So let's think about how you're doing that. If I tell you that one is 30, to get the other one, you're going to do 180 minus the angle that I give you. Well, this time, I'm not telling you how big the angle is that I'm giving you. I'm just telling you that it's there. So it's going to be written as 180 minus x. So when we set up our problem, this is going to be 2 times 180 minus x. Now notice I'm not adding these together to equal them 180. It's comparing the 2 angles to one another. The measure of one angle is twice the measure of the other angle. So now if I do some kind of quick algebra to work this out, I'm going to have x equals 360 minus 2x. That's 3x equals 360, or x equals 120. And then if I go to think about then what my 2 angles are, my first angle, it says is going to be, oh, I wrote that wrong. My first angle is going to be 120. I said 120 and wrote 180. 120. All right, and then my second angle is going to be, we said that that was 180 minus x. So if I do 180 minus 120, that means my second angle is 60. Now read back through your problem and let's see if that makes sense. The measure of one angle, 120, is twice the measure of another angle, 60. And those 2 angles together, 120 plus 60, is a supplemental pair. And that's true. When you add those together, you get 180. You may need to pause and rewrite that or take some other notes for a question of that level. All right, so we're on to the 4.2 part of our notes. And here we're going to be talking about some more angle relationships, particularly when we get more lines intersecting one another. So we'll start with parallel lines. We know those are 2 coplanar lines, meaning they're both going to be in the same plane that do not intersect one another. So a few quick notes about parallel lines. One, if they ever tell you lines are parallel, they're going to write it looking like this. A is parallel to B. All right, so that little like slash symbol is just showing you that the lines are parallel. If you ever see them in an image given parallel, so like lines have arrows on the end of them, the way they note that in a figure is to put these little arrows on the lines, and that just indicates that those lines are parallel if they don't actually tell you that in words or symbols somewhere else. All right, a transversal is a third coplanar line which is going to intersect 2 other lines. Now that doesn't mean, like, transversals can happen even if lines aren't parallel, but in this image, for example, at the bottom, I've got these 2 parallel lines that are running horizontally, and then this transversal is the line that is intersecting both of the others. It's kind of cutting through. That's what they call the transversal. So notice, we've got this picture. We've got all these different angles, like 1, 2, 3, 4, right? 1 and 3, so first of all, these are not angle measures. These are names of angles. It's just a quick way, instead of having to use 3 letters and trace that out over and over and over again. All right, so you know things like angle 1 and 3 are vertical, so they're congruent, right? 2 and 4 are vertical, so they're congruent. You also know that 5, for example, 5 and 6 form a linear pair, so together those equal 180. Same with 7 and 8, right? There's linear pairs and vertical angles all over this picture. But if these 2 horizontal lines are parallel, so we're going to kind of make a note of that, right? You may want to draw the 2 little arrows. If they're parallel, there are actually some other relationships that we can see. So think about what we talked about, rotational symmetry. If I take this figure right here and I twist it, you're going to notice it does have 180 degrees of rotational symmetry. So think about if you took this image and you twisted it, what it would land on. All right, so this is what I mean by that, right? Currently, 1 and 3 are congruent to each other, and 2 and 4 are congruent to each other. I think you're okay with that. Now think about if we pivoted this image maybe around a center point right here. If I rotated that 180 degrees, it would line up perfectly with the bottom, which would mean then that 3, that's not the color I wanted, I'm sorry, that 5 and 7 are also congruent to 1 and 3, and that 6 and 8 are going to be congruent to 2 and 4. Okay, the last thing that I want to point out to you when you think about this, you told me, so just kind of think about our colors here real quick. You told me that 1 and 2, we're going to make a linear pair, right? The green and the yellow together make a linear pair. So we see those all over, but another place I want you to see them is this section right here in between. So even though these two are not making a linear pair, these are going to be supplementary. All right, so we actually have some names for all of these different angle relationships. All right, and if it were me, I would not necessarily write down all of these like definitions. I would write down the words though and the angles that correspond with them, and you may be able to come up with a shorter way to have definitions. So our corresponding angles, again, not what I meant to do, our corresponding angles are going to be angles that lie, to me, they lie in like the same position. So an example would be, they're giving us angles 1 and 5. Those are corresponding. Okay, another example of corresponding angles might be like 3 and 7. Notice how they're kind of in the same position. Sometimes I even like to think about that as if this is like a, desk grouping or roller coaster cars or something, right? The people at 1 and 5 are sitting in the same spot. The people at 3 and 7 are sitting in the same spot. Okay, and then we've got same side interior, which means they lie on the same side of the transversal, but interior is between the two parallel lines. So, for example, all of this yellow section in the middle is interior, which means everything else would be exterior. That's kind of how they're defining that. So same side angles that are both in between, the example they're giving me here are angles 3 and 6. And we said that those are supplementary. The way that I remember that is if we just think about our letters here, right? We've got same side supplementary. That is true for same side exterior angles. So an example of same side exteriors would be like 1 and 8. Okay? All right, then we've got alternate interior angles. Those are on opposite sides, so alternating sides of the transversal. But they're both interior, which means in between the lines. So an example of that would be 3 and 5. Those are going to be congruent, just kind of like we showed just a minute ago. Another example would be 4 and 6. All right, and then we also have alternating exterior, which are very similar in their setup there. It's just that we're now talking about angles that are exterior. So that's like 1 and 7 there. Or another example would be 2 and 8. And what I want you to make sure you have in your notes is that corresponding angles are going to be congruent when lines are parallel. So you may want to make a note that this is when and only when lines are parallel. Corresponding angles are congruent. Same side angles are supplementary. Alternate interior angles are congruent. And alternating exterior angles are congruent. So really, for the most part, everything is going to be congruent when we find the pairs other than same side, which is why I showed you that SSS kind of relationship there to help you remember. All right, so let's just do 2 quick examples just so you feel better about these relationships and how we might use them. So the first thing I want you to do when you see a problem like this, and these should be noted as parallel, sorry. The first thing I want you to do is name the relationship that you're going to see. So these 2 angles they've given us on question 5, that's an example of same side interior. And because these are same side interior, we know they're going to be supplementary. All right, so when I set this one up, I know I can add these 2 together, and that can give me 180 degrees equals 180. And then if I solve this out, I changed the numbers so we didn't have to worry about decimals anymore. All right, that's going to give me 8x equals 160, so x is going to be 20. And what's nice about these is that doesn't just give me 2 angles, it actually gives me 8 different angle measures. Because notice, if I plug this in, I'm going to get 60 here. If I plug it into the other one, I'm going to get 120, which we know those are supplementary. But using vertical angles and some of the other relationships we know, we can fill out everything else, right? All of these acute angles in this image are going to be 60 degrees, and all of the obtuse angles are going to be 120 degrees. All right, example 6 is just a little bit different. So let's start again by naming what the relationship is. And this time, these angles are in corresponding spots. So we are going to call these corresponding angles. And we know that corresponding angles are congruent. So I can set this up equal to each other. 5x minus 10 equals 3x. And then when I solve this one out, let's see, 2x, we've done this before, 2x equals 10, so x is 5. And I plug that back in. Let's see, that's going to give me, should give me that both of these angles are 15 degrees. Now you may think, oh, well, that's a problem. Now I can only find a few of the angles, but that's not true, right? I can fill in all of these acute angles, but remember, the others all make linear pairs. So I know that these other angles all must be 165 degrees. So these transversal problems are pretty cool because you can solve a lot of information with just a little bit of knowledge.